Welcome back to part 3 on getting information from graphs. Again, I've set up our list of items we need to find for this function, and we do have a few more restrictions on the domain now. Notice that there is a fraction in this function and there is a variable in the denominator, in which case we do have to restrict our domain so we do not get undefined outputs. So we will have to throw out x cubed equal to 0, which means x cannot equal 0. Let's go ahead and graph this in a calculator. We want to turn on the calculator, go to y equals, clear any items that are already existing in there, and then we're going to put parentheses around everything in the numerator and then divide it by something with parentheses in the denominator. Remember, this is very important because if you don't do this, it's only going to divide this negative x squared with the x cubed. You have to group everything in the numerator separate from the denominator. Now, some of your calculators will default to a fraction, and it just auto-formats everything for you. And aren't you lucky? Because not all the calculators will do that. Also notice, if you don't arrow out of the exponent, you get this little miniature parenthesis here, and we don't want that. So delete that, arrow out of the exponent, close parenthesis. Now hit graph. All right. Now, I want to show you what happens when you don't set your window to the correct size. You get this weird looking thing. So remember, use the window that's given and round to 1 decimal place. Click on window. Change your window from what is already in there. Sometimes it will be a default, but we're going to put from -5 to 5 and from -1 to 1. Now remember, these little negative symbols are the negative right here down at the bottom of the screen. This is not the minus sign. Now let's graph it. That is a much more interesting graph than the first one we saw. So a few things. You have to remember to put parentheses to group your numerator and denominator separately. And you also have to remember to listen to what your window interval is supposed to be, or it's not going to be very helpful when you are looking at the graph. I'm now going to quickly sketch this graph on paper so you can follow along with where my maxes and mins are going to be. We now have the general sketch of this graph given on the calculator. I need to find where this function is increasing, where it's decreasing, etc. So again, I'm going to highlight the domain values for which this function is increasing. So from -infinity all the way up to this high point, the function is increasing. Then its shape turns downward and it starts to decrease. Similarly, we continue looking at this and it keeps approaching this vertical asymptote at 0. Now remember, there is a vertical asymptote at 0 because x cubed cannot equal 0. So there is a vertical asymptote at 0. And then from this low point on the right of 0 onward to positive infinity, the function approaches the horizontal axis. So that's an increasing function. It doesn't approach it very fast, but it definitely is going there. So we need to find these points, this high point on to the left of 0 and this low point to the right of 0. And we can do that with our calculator. We want to push second, calc, arrow down to maximum because we are finding this point first on the left. find the left bound. And you may have to watch your x and y values to figure out where your little cursor is. We want to go to the left of the high point, then go to the right of the high point, and then guess the high point. Enter the third time, should give us a maximum. Now we need to round to 1 decimal place in this case, so our maximum is going to be at negative 1.7 and 0.3, 0.4, because the 8 makes the 3 round up. Second, calc, minimum. Now we're going to have to hop this vertical asymptote, so we're going to have to keep arrowing to the right until we see the cursor appear. There it is. Click left bound, arrow to the right of the minimum, gives us our right bound, guess our minimum, enter a third time, from negative 1.7 to 0, the function is decreasing. It is undefined at 0, and then it is decreasing again from 0 to 1.7. So we now have enough information to list all these intervals. This function is increasing on the interval from negative infinity to negative 1.7, and also from 1.7 to infinity. The function is decreasing on the interval from negative 1.7 to 0, but remember a vertical asymptote breaks that up, and then from 0 to 1.7. The domain of this function is all real numbers except for the vertical asymptote value, and that was at 0. So we would say negative infinity to 0, union 0 to infinity. The range, if we look at this, it might be not so obvious because it has a maximum on the left side of 0, the function does, and the function has a minimum on the right side of 0. But if you look at the whole graph all together, there are no breaks vertically. So your range is from negative infinity to infinity. Your local maximum is at the point negative 1.7.4. Your local minimum is at the point 1.7 negative 0.4. Your universal maximum does not exist. And your universal minimum does not exist. Because if you look at this function, it continues to move upward as the domain values get closer and closer to 0 from the right. And the function decreases to negative infinity as you approach 0 from the left.